How do you define it? Very simple term. Force over area, right? Force per unit area. So let's say you have a column of liquid. A container where it is completely filled with liquid. Okay. Now, the force acting at the base of the container is the weight of the entire liquid, correct? Yes, right? So the weight of the entire liquid pressing at the bottom of the container. So the weight is mg. I can also write the force, mg, and pressure is force per unit area. How much force is acting on one unit area? So if I put it in my equation, I get P equals to mg over area. Okay, mg over area, and also I know the density of liquid is mass per unit volume. So mass is equals to density times volume. Again, I put it here. I get pressure equals to rho v g over A. Okay, now the volume is equals to the area of the base times by the height. What height? The height of the container. Okay, so the height of the container, because we are assuming that the container is fully filled with liquid. So put it in equals to rho times A times H times G over area. Then we can cross off, we get what? H rho G. This is the expression that we use for water pressure. You see, it depends on what factors. The pressure of water depends on the height. This is actually, we call the depth from the surface. Okay, depth from surface of water. So since the water is fully filled, then we just take the entire height of the container. So if the water is filled until here, then you want to calculate the pressure of this liquid at the base. Then you are going to take the height from this surface here. Okay, so it's the depth from surface. And the rho is the density. Density of what? Density of whatever is the liquid here. If it's water, then 1000. If it's mercury, then you have different density. And then the G, of course, it doesn't change. That is the gravitational constant. Now, pressure, unit of pressure is in Pascal. Okay, Pascal, PSCL. There are many units, but here in the H rho G, we use Pascal. Now, if you think of pressure, what is actually pressure? Is actually the weight. When I say liquid pressure, right, it is actually the weight of the liquid sitting on top of you. Imagine if you go diving, you go underwater, and then the deeper you go, what happens to the breathing? It becomes very difficult. It becomes something like pressing on your lungs, right? So the deeper you go, the pressure of the water gets increased. And as the pressure gets increased, it presses the lungs, preventing the lungs from expanding. That's why you feel like something is on your chest. Something is pressing you. That is the water pressure. Where does that come from? That comes from the weight of the entire liquid that is above you. Okay? The entire liquid that is sitting on top of you. It's like you are bearing the weight on top of you. That's where the pressure comes. Okay? So pressure is actually weight. Is the weight of the liquid. Just that we divide it by the area. That's it. Okay, huh? Now, here, it depends on two things. You can see, so the depth and the density. The deeper you go, the higher the pressure, which is why when you go to the dam, the reservoir, the hydropower plant, okay, they have this dam holding the water, okay, very huge amount of water, they hold it. And then if you look at the wall of the thickness of the wall, the construction and the design is that it gets thicker and thicker as you go deeper and deeper. Okay, the dam, it looks like this here. This is the wall, and then it gets deeper and thicker. As you go down, it gets thicker like that. Why like that? Because the pressure of water at deep region is very high. You need a very thick concrete wall to withstand the pressure. Otherwise, it will break. It will break. Okay. So same thing. This is one evidence of pressure increases with depth. Another evidence is like if I do a hole here, I poke a hole here, you see the water flowing out. And if I do another hole at the down here, you can see that the water flows out at a longer distances, which means the pressure is higher. The same thing you see in the water tank. If you live in condominium apartment, the water tank at the top, they place it at the very top. Why do you want to place it there? So that the water flows to your house with the help of gravity. It doesn't need any pump to do it. Of course, it needs a pump to pump the water up first. Pump the water up to the water storage tank. Okay, if the building is very high, then maybe they need two water pump to pump it, and then pump it until the rooftop. Okay, where do they place it? They place it at the just under the roof and inside the attic. Okay, inside here, just under the roof, inside the roof. Okay, the water tank, they place it there, and then it goes down to your pipe. What is the water pressure when you open the pipe? The water pressure, this is the tank. Okay, this is the storage tank. And then it goes down, let's say your condominium is 15th floor. Okay, and it goes all the way down to, let's say you stay at 7th floor. 7th floor, this is your water tap. When you open the tap, what's the pressure? The pressure here is measured from the height from the surface of the water in the tank to your pipe over here. Okay, that is the height, that is the depth. Okay, so you can also calculate what is the water pressure as you open the tap. Here, P equals H rho G. Okay, you get here. So that high pressure pushes the water out. Okay, so same thing with the heater, the shower heater. Okay, you can see heater with pump and heater without pump. With pump, the water comes out with force. Without a pump, the water comes out like very weak. Okay, so that is the difference with pressure with and without a pressure pump. Right, huh? So that is just a few applications of the pressures. Now we look at gas pressures. So that is liquid pressure. Huh? Gas pressure comes from where? If I have a container that I capture gases inside, the molecules of the gas moves randomly in random direction. And as they move, they strike the wall of the container. When they strike the wall of the container, what happened? How do you explain it in physics? When they strike the container, what will happen? You have learned about momentum, right? So let's say you get one particle, go and strike the wall. This particle is having a certain momentum, mu. It has mass, it has velocity. Strike the wall and then it bounces. Now the particle bounces off of it. The mass doesn't change, the velocity changes. There is a change in momentum. What happened when there's change in momentum? F equals to mv minus mu. Impulse. If I move the t over there, mv minus mu over t. You get this. What is this? Impulsive force. Whenever there's a change in momentum, there's a force produced. On where? The particle hit, bounce, change in momentum, the force is produced on the wall, on something that it hits. So here you have the force produced on it. It's a very tiny force because the particle is very small, right? Very tiny force. That's the impulsive force. Okay, but this tiny force is added up. You have millions of particles, right? So they add up the total forces acting on the wall of the container. If you divide it by the area of the container, you get the pressure inside the container. So again, P, force over area. This is total of the impulsive force. That in essence is the atmospheric, is the pressure of gas. Okay, so pressure of gas comes from where? How do you explain it? Comes from collision. Whenever there's collision, there's change in momentum. Okay, I'll write this down here. Collision, there's change in momentum, and there's force. And with the area of the container, with the wall of the container, you get pressure. Okay, huh? Right, then how about atmospheric pressure? This is pressure of gas, of a captured gas, of stored gas. What about pressure of atmospheric? It's the same thing. Pressure of atmospheric, just like pressure of water, it is the weight of the atmosphere. The atmosphere also has a weight. So the weight of the atmosphere is sitting on everybody on the earth, every single object. Okay, what is the weight of the atmosphere? What is the pressure of the atmosphere? 15 psi. Sometimes you see there are many different units. One unit is psi, pound per square inch. Okay, what else do you have? You have like the 1 times 10 power 5 Pascal, right? This is also the atmospheric pressure. This is the value that you need to remember. In the exam, you need to remember it. Okay, so 15 psi is the pressure of the atmosphere. What does it mean? Now, let me give you an idea of what is this one. 15 psi. Psi is pound per square inch. Meaning that if you take 1 inch, 1 inch measured like this, and 1 inch measured like this, you get 1 square inch, like a tiny area. Okay, that's tiny area, 1 square inch. If you take 1 square inch like this, and then you extend this one to the edge of the atmosphere. Okay, you extend this column to the end of the atmosphere and to the ground, stretch it. That entire column of air weighs 15 pounds. Okay, so I'm inside the atmosphere, right? So that means if I take 1 square inch, 1 square inch, 1 square inch, 1 square inch, all this 1 square inch on my hand add up. 15 pounds, 15 pounds, 15 pounds, 15 pounds, 15 pounds. How much weight am I bearing the atmosphere? 15, 15, all this add up. It becomes a very large force, right? So the atmospheric pressure is actually a very large force. But the question is, how come we don't feel it? If so many 15 pounds, 15 pounds, 15 pounds is pushing you, is pressing on you, then how come you don't feel it? The reason is because the pressure of liquid and gas, they act in all directions. Let me explain. You see, you stand here, you have 15 pounds pressing on you from the top. Also, you have 15 pounds pressing on you from the bottom. You have also from the side over here. All of this 15 pounds, they act in different directions. This happens in gases and happen in fluid. Okay, fluid can mean water or gas. It happens in all fluids. That is, the pressure in fluid acts in all directions. Let me write it here. Pressure acts in all directions. So if you have 15 pounds here, bottom, left, right, they all cancel out. They all cancel out, so we don't feel it. We don't feel the pressure. That is the reason why, because the forces are balanced. Okay, but this is one characteristics of the pressure. What is the characteristics? Pressure in fluid acts in all directions. So if I put an object, a ball inside the liquid here, what is the pressure acting on this one? You have the pressure here, you can calculate P equals to H rho G, and also you know the pressure acts in all directions, from bottom up also. Bottom up, left, right, like that. Okay, so that is one property of it. What happens when one side becomes zero? If this 15 pound here, suddenly the pressure acting from you at the bottom becomes zero. What happened? You will feel the 15 pound straight away press you. If the pressure acting upward suddenly becomes zero, then you feel this pressure pressing on you. Because one side got pressure, the other side there's no pressure. It will crush you. This is what happened when you go outer space. When you go to outer space, if you don't wear a suit when you go outer space, because the suit, the astronaut, the suit provide this pressure inside. So they wear the suit, they create this pressurized condition to keep their organ stay in normal condition. So if you go to outer space without a protective gear, what happened? In outer space, is there any air molecules? There's no air molecules. There's no air. No air means no pressure. Zero. So if you go outer space, your surrounding pressure is zero. What happens inside your body? Inside your body, you got your blood pressure, right? All the fluids has pressure. So inside got pressure, outside no pressure. What happened? Burst. Yes. Okay. So pressure goes from large, they go to, because of the surrounding pressure is zero, right? So there's a force acting from inward, acting out like that. Okay. So that's why, that's how high pressure and low pressure condition can produce a force. When you have a difference in pressure, there will be a force produced. Okay, I repeat, when you have a difference in pressure, there will be a force produced, just like the person here. 15 pound downward, 15 pound upward, there's no difference. I remove the 15 pound, now you have a force pressing downward. That is a difference in pressure, force produced. Okay, so that is the reason. Now, this is on liquid and gas pressure, just to give you an idea of what is it. And also you need to be able to explain when the question asks. Now here, next one, we look at how do we actually know the atmospheric pressure is 1 × 10⁵ Pascal or 15 psi. How do we know that? How do we calculate? And how can we calculate the pressure of atmosphere at different levels? As I go up, altitude, or at sea level. As I go up, does the pressure increase or decrease? The pressure decrease, right? Because you have less air up above. So the pressure decrease. At sea level, you go down, the pressure increase. Okay, let's look at one experiment setup of how can we calculate pressure of gases. I'm going to erase this one. If you want to capture it, you capture first. Then I will go to the next slide. So far it's okay, not lagging. If it's lagging, you let me know in the chat. Okay, now very, very long time ago, I think in the year 1643. Wow, very long time. There was a scientist. He took a test tube. Okay, he took a test tube. And then he filled this with mercury, Hg. And then he take this one, invert it, he put it inside a basin of mercury, like this. Here it fills with mercury, and also the test tube filled with mercury. And what he observed is that this mercury rises to a certain height, and he went and measured the height. Which height? From here, the height, the surface of the column, okay, the column inside the test tube, until the surface of the mercury here. He went and measured this height. He found that this height is 76 cm. Okay, he found that it is 76 cm. No matter where he go, as long as he is at the sea level, he take this, move here and there, he found that the height remains 76 cm. If he tilt this one, 他把它打斜 ，OK， 他不管怎样，他推下去，他打斜拉上来，他都是算到这个 height 是 76 cm. Now, here, what happened to the pressure? How does the pressure act on this thing here? You see, pressure in liquid. One characteristics of pressure in liquid is that pressure is the same as at the same height. Pressure same at same height. Okay, all these things you need to remember. First one is pressure same at same height. Another one is pressure, this one I written down just now, X in all direction, right? And the third one is that when the depth increases, pressure increases. Okay, so the first characteristics of pressure is that it says that at same height, the pressure is the same. That means if I draw a line, at the surface of the mercury in the basin, this orange line, this is the same height because I measure from the base. Every point on the line is same height. That means at that line, all the pressure is the same. Okay, if I take one point outside, point A, okay, point A, outside here, what is the pressure acting on point A? It is at the surface of the liquid, right? You ask yourself, what is pressing on point A? Is there any liquid above it? There's no liquid above it, right? So there's no liquid pressure. Is there any air above it? Yes, atmosphere. So atmospheric is above it, so atmospheric pressure is acting on point A. Here I write P ATM, atmospheric pressure. Okay, now I pick another point, point B, inside the tube here. Point B. Same pressure, same pressure is acting on point B. What pressure is that? Is there anything above the P, above point B? You have a liquid above point B, right? You have a mercury column, this one inside, above point B. So the pressure acting on point B comes from the mercury column here. I label again, this one pressing down is PHG, that is pressure of the mercury. And on top of the mercury, there's a vacuum here. This very small, tiny space is a vacuum. There's no air inside. Okay, so that means he removed the air. So if there's no air, there's no pressure. So that means all the pressure acting on point B is from the mercury. And at point A, all is from the atmosphere. Now, pressure at the same height is the same. So I can write PA equals to PB. PA equals to PB. So PATM equals to pressure of the mercury. Okay, how do you calculate the pressure of mercury? You have learned it, pressure of liquid, H rho G. So H rho G of mercury. Now we get an equation. The atmospheric pressure can be calculated by the H rho G in this barometer. Okay, so what is the height that he observed? 76. Okay, 76. So we put 0.76 times the density of mercury. What is the density? This, okay, is given usually in a question, 13600 kilogram per meter cube. Okay, kg per meter cube. This is in meter, SI unit, and then times by G is 10. Okay, calculate this. 1366 10 times 0.76. Okay, we get 103360 Pascal. This one, usually it can be written straight away as 1 times 10 power of 5 Pascal. In the SPM, it's okay to use this value. You don't need to use 103360. It's okay to use 1 times 10 power of 5. Okay, but if the question gives you this one, then you use this one. Okay, so what is this pressure? This is the pressure of atmosphere. Okay, at whatever level that he's carrying this experiment, at sea level, atmospheric pressure. Okay, and we get this 1 times 10 power 5 Pascal, right? You see there are many units for pressure. Just now I mentioned there are 15 psi, that is also atmospheric. And from here, we can also write it as 76 cm Hg. Okay, 76 cm, that means the height is 76 cm and Hg is mercury. So this, I can also write my atmospheric pressure as 76 cm Hg, no problem. And I can also write my atmospheric pressure at 760 millimeter silver. Sorry, not silver, mercury. Like that. Okay, 760 millimeter Hg. Or there's another one, 1 atm. All of this 1, 2, 3, 4, 5 is the unit for atmospheric pressure. So I will write it here, P atm equals to 1 times 5 Pascal, 760 millimeter Hg, 76 cm Hg, or 1 atm. Which one to use? Depending on your question of calculation. If the question of calculation given Pascal, you use Pascal. If given the cmHg, you use cmHg. Okay. What is this thing called? This thing is called mercury barometer. What is the main use of mercury barometer? To calculate atmospheric pressure. No matter how you move it, as long as you are at the sea level, the height will always be 76 because the atmospheric pressure doesn't change. The only way to change the height of the mercury is to go to higher places. Okay? Go to higher places where the atmospheric pressure changes, then you will get a different length of the column. And again, I want to emphasize one thing. The length of the column is measured from where to where. Where to where? Be careful this one. This is your test tube. Here. This is the surface of the mercury. The length is measured from inside the level to the surface here. Okay, where is our point AB? Our point AB is over here. Not at the base here. Okay, this is B. A is outside here. Point C. C under B, that is not correct. Pressure at A is the same as pressure at B. You need to remember that they are in the same line here, this line. Okay, so that is something to take note. And here, some question they give you, like, let's say here is there's a gas X. What does the gas X do to the pressure at B? You can derive a new equation. From here, pressure at A is same as pressure at B. Pressure at A is ATM. What is pressure at B? H rho G. This is from the liquid column, right? You need to add the pressure of gas X. So if the pressure of gas X is given, then you can put it in. This is your equation. No need to remember the equation. Most importantly, you understand how I get this equation. It's from the first property, pressure at the same height is the same. Now, why the mercury barometer? We use mercury. Can I use water? Yes, I can use water. But see what happened if I use water. Here. I take the same mercury barometer. Now I fill with H2O. Okay, point A, point B. PATM equals H rho G. If I use water, you will see that there is a change in the length of the column. If I want to calculate the length, how do I calculate the length? Using this expression, I already know the atmospheric pressure, right? If I do this at sea level, our current level, our atmospheric pressure, okay, I put in 1 times 10 power 5 Pascal equals to H. The density of water is 1000 times 10. You calculate this, you get H equals to 10 meter. That means if you use water, you will see that the column become so high, 10 meter. There's like a few stories. So is that practical? Is that portable? Do you have that long barometer? It's not practical. So that is why we don't use water for our mercury barometer. Simply because water is much less dense than mercury. 1000. The density of mercury is what? How many? 13.6 times heavier than water. Okay, so if you change the liquid to water, then it will be 10 meter high. Okay, 1 to 2 minutes. Then we go to the next slide. Okay, give me 1 minute. I will be back in 1 minute. Okay, like continue. Okay, you try this. Oh no, not this one. This one. Two examples. Let me draw it for you first. I draw the diagram. Okay, a few minutes and we look at the answers. Okay, let's look at the answers. The height of a mercury in an open barometer is 69. The height of another fluid in a barometer is 176. What is the density of this fluid? Okay, we take the point that is the same as the atmospheric pressure. So this point here and this point here. PATM, let's call this point A, and this is point B. I can write PATM is the same as the pressure at point A, and also it is the same as the pressure at point B, right? Because these two barometers, they are at sea level together. Okay, so the pressure is the same. PA equals to PB. So PA equals to PB. Now PA is the pressure. You look at what is pressing it. This amount of liquid is pressing it. There's no gas inside here, so zero pressure. So all the pressure comes from the H rho G. H rho G equals PB is again H rho G. That is for the liquid. This is for the mercury. Okay, so 69 times the density 13600. The G I can just cancel off lah. Cancel off. So equals to 176 times rho. Okay, so rho is equals to 5331.82. So approaches 5332. Example 2. The height of water and oil are 6 meters and 5 meters inside an open barometer. What is the atmospheric pressure in kPa and ATM? Okay. So now, same thing, we do the same thing. Point A over here, pressure ATM equals to pressure A. But then pressure A, how many pressure is acting? On top of it is this column of liquid. This is water. Water is pressing on it. So P from H2O plus the P from the oil. And there's no gas above it, right? So just like that. Equals to H rho G for the H2O plus H rho G for the oil. Okay, so 94080 Pascal. That is in Pascal, right? So kilopascal, we just do 94.08 kilopascal. And then also the question wants in ATM. What is 1 ATM? 1 ATM is atmospheric pressure, right? So 1 ATM is equals to 101.325 Pascal. So how many ATM is this one? You just divide it. Okay, next one. Now here we will look at the YouTube manometer. The YouTube manometer is very similar to the barometer. All the things that we learn applies the same here. Okay, so let's say I have two types of liquid. Fill up the barometer, sorry, the manometer here. Here, fill it with water. Now, when you fill it with water, just one type of liquid, you'll see that it goes equal height. Okay, you fill the water and then you see that they go like equal height. That means the pressure over here, point A, at the surface, is the same as the pressure here at the surface, point B. Okay, PA equals to PB. But when I add in another liquid, say I add in oil, then this thing is going to change. It's going to adjust. Because I have another liquid coming here. It's a different density, right? It's a different density. So the pressure, because pressure H rho G depends on the density as well. So if I add in the oil, let's say I get something like this. And this is, say, 50 cm. And over here. Okay, so here on the right column, the water level has rises when I add the oil in. And the oil, considering that they do not mix, that means they do not get mixed up. Okay, they are two immiscible solids as liquid, immiscible liquid. Okay, now the given the height here is 15 cm. Now I want to calculate what is the density of the oil given this YouTube manometer like this. How do I calculate the density of the oil? Okay, back to our first rule. What is the rule again? The rule of pressure is that at the same level, pressure is the same, right? Pressure, same, at same height. Now, this one applies for the same liquid, remember, same liquid type. If you have different liquid, same height doesn't necessarily have the same pressure. Another means that if I take this point here, point C, and this point here, point A, they do not have the same pressure. They do not necessarily have the same pressure because this is water, at point A is water, and at point C is oil. It's not the same. Okay, it's like when I take two measuring cylinder. Okay, measuring cylinder, and I fill one with water, one with oil. At the same height, the pressure is going to be different. It's not the same. So this one pressure same at same height applies for the same liquid. So that means if I want to find the same pressure point on this YouTube manometer, where is it? I have to find 2 points that has the same pressure, just like my point A and B here. Okay, it's at the surface here, at the surface here. Okay, so very simple, we do at the surface of this water, okay, at the surface of the water, and we draw a line crossing over here. So I draw a line like this. We always draw a line at the surface of the liquid. That means any point on this line has the same pressure. So this is point A, this is point B. Okay, so it's the same liquid and the same height, same pressure. So now I know PA equals to PB. Then I can find out what is the pressure acting on point A. All the pressures, okay? So you have Again, you ask yourself, what is pressing it? The oil is pressing it. So we have the pressure of the oil. What else? You see the up here is open. Up here is open. That means atmospheric pressure can come in. Okay, here is open tube. So atmospheric pressure also press down. You have P ATM as well. So P oil plus P ATM equals pressure at B. Okay, this column, what is the height here? You get the height first. This height here equals to 50 minus 15. Okay, 35 cm. Okay, so here PB is P of H2O plus again ATM because you have another exposed tube. Okay, but the ATM you can cancel, then you have P oil equals to pressure of H2O. Then you do the H rho G thing. Okay, H rho G equals to H rho G. Change to meter 0.5 and then times rho. We don't know the oil, so times 9.8. Okay, or you use 10 equals to, this one is 0.35 times 1000 times 9.8. Okay, we get 4.5, 4.9. Rho equals to 3430. And the density of oil is 700. Okay, so 1 minute and I erase this. Okay, try this. Question 2 on the left. Okay, same, we draw a line at the surface, then AB. The density of oil, we use this one. Okay, so you get this 0.21 meter or 21 cm. This height is from where? Here, from here to here, this is the 21. So the hedge, you take 30 minus this one, you get 9. This one, maybe I should write y, h2, h2. Okay, so h2 is the 30, 21, and the h is the one that we want to find. Okay, example 3. Where is the equilibrium pressure? The same pressure point. Can I draw it here? Cannot, right? It's not the same liquid. Huh? On your left, you have oil. On your right, it's water. So we take the bottom, at the very bottom. Okay, where both types of liquid exist at the bottom. Okay, so that means if you're at the bottom, then I just use whatever is the height. This one and the 80 cm. Okay, so I'll send you a few exercises. Huh? Okay, give me a minute. I'm going to send the PDF in the group. 答案在后面呢，后面我有第二份呢，我现在第二份。 OK，我要讲一下第11题啊。Okay, I want to talk about question 11. If you look at question 11a, figure 3.1 shows a mercury manometer connected to a gas X. And figure 3.2 is a mercury manometer. So you can see that this is also a U-tube, right? A U-tube manometer, but then you have gas X entering from here. That means everything else is the same, just that if I take the 2 points here, point A and point B here, what is the pressure acting on point A? You see what is pressing on it? Gas X, right? So gas X is acting on pressure point A. So PA equals PB. That means P gas X is going to be equal to PB. So PB is the 14 cm, right? So that's the H rho G. And then don't forget you plus the atmospheric, because you can see the tube here is exposed. So you have P ATM pressing as well. So P ATM. Here you get the equation. P gas X equals to H rho G plus P ATM. Okay, so you always want to be careful whether the tube is open or not. If it's open, the total pressure acting on point B is the column and the ATM. Same as if the question give you like this, the question asks you to calculate what is the pressure at point A under the sea here. That is 10 meters under. What is the total pressure acting at point A if it's under the sea? So how do you calculate this? Not just doing this, P equals to H rho G, then you do 10 times 1000 times 10. You get what? 345, 5 zeros. Pascal. Is this your answer? This is not the total pressure, remember, because you also have atmospheric pressure. The water press on point A, the air also press on the water. So it's going to add up. That means the P total at A is going to be 100,000 plus the atmospheric pressure. Okay, so it's going to be 200,000 Pascal. This is the total pressure, or sometimes you see they say the absolute pressure. Absolute 的意思就是 total. Okay, so 11A number 2, how do you calculate the pressure of gas X? Here I have written the equation for you. Same for the gas Y. Okay, so for gas Y, I draw a line here. This is equal pressure line. Point A, point B. PA equal PB. PA 有什么？有这个8 cm 的 liquid mercury. So 我写 PHG， 这个我直接写 H rho G 啦。 H rho G 这个是那个 mercury column，再加上你有 gas Y 进来对吗？你有 gas Y 进来，你就没有 atmosphere 咯，所以你这个是 P gas Y 等于 PB 单单是 atmospheric pressure。You have this, then you can calculate gas Y using that equation. So you see the question is almost similar. U-tube, manometer, the barometer. In the end, you always want to find what? The same pressure point, and you want to find out what pressure is acting on that point. Then you get the expression. You can find any unknown. Okay, so the rest, I leave it to you. If you have any questions, I'm behind the screen. Let me know in the chat.